Okay, kids. So here's the thing. Oh, it's frozen first. So you're trying to prove whether converges or diverges, right? If you can evaluate an integral, great, it works. The challenge with this is you can't really you can't evaluate this thing. There's nothing to evaluate. So what should you focus on? What structural element of this integral should you focus on? What's the most interesting element, do you think? The what?
The fact that like
it alternates. Which specific part of that causes that? Which specific part of the numerator? Yeah, so let's go real micro here. It's sine of x right there, right? What do we know about sine of x? When they say sine of alpha, it's less than or equal to what? 1, and it also always is greater than or equal to? So let's look at the extreme on the right. Let's look at the bigger extreme first, okay? Let's look at the bigger extreme. Let's just say it was 1 the entire time. If we replace sine alpha with 1, if we replaced it, would we be making it bigger or smaller? Bigger. So you know it has to be less than or equal to 4 to infinity of 3 plus 1 over alpha d alpha, which is the same thing as what? 4 integral from 4 to infinity of 1 over alpha d alpha. Now what do you know about this integral right here? What does that do? You know, what is it analogous to? It is the harmonic, right? Bigger than the harmonic. So what's it going to be? It'll be divergent. But here's the thing. We just had a ceiling that diverges. Does that tell us anything? No. If the ceiling blows up, that doesn't tell us anything about what's under it. So we went to one extreme. We went to this extreme. What's the other extreme we could go to? The negative one. If we do that, we know that will get smaller than what? 4 to infinity. Instead of 4 up there, you're going to have 3 minus 1 over alpha d alpha. So what's that going to be? 2 times 4 to infinity of 1 over alpha d alpha. But now we are above that. The original is above this thing. Yeah. So we're above something that diverges, so therefore what has to happen? It diverges.
So the comparisons are all the same as like comparing summations, or are they?
How'd you feel about number 9? What does sketching a solution mean on a slope field? What does sketching a solution mean? You have a slope field, you plot the point, and what do?
You find a graph where it could match.
Exactly. The phrase I want you to remember is go with the flow. So if this is the slope field right here, and you picked a point, say right here, if you went with the flow, this is the path you would end up with, right? But let's say you started at this point. What path are you going to end up with? This path instead. Let's say you started at this point. What path do you end up with? Plotting a solution is going with the flow. So if you have a slope field, you estimate where you would go if that was a current and you were on a boat that started at that point. So these questions are important. Sketching you will almost certainly have to do. It's really common on the BC exam. From your sketch, write the equation. Anybody come up with the equation for B? It's right there in front of you. Like, there it is.
Y equals negative x.
Negative x what?
-1.
Yeah, that's it. Part C is kind of a trick question, unfortunately. Anybody do part C? Yeah. It says check your solution part by substituting it into the differential equation. Now, the key is by substituting it into the differential equation. That's the important thing. How do you solve a differential equation normally? If I asked you to solve this differential equation, do you know what solving a differential equation means? You've seen it before. It means differentiated or integrated. Which one? Integrated. What's the challenge with this one that's in the blue box? There's a word that you might have seen before. dy dx is equal to x plus y. If you were going to integrate that, what's the first thing you need to do? I'm just checking to see if you've learned this term before. Anybody remember what it's called? You have to, what'd you say? You have to separate the variables. All the dy's have to be attached to the y's, and all the dx's have to be attached to the x's, right? Here's the challenge. Are all differential equations separable? No. Is this separable? No. So is this nicely integrable? So when they say by substituting, don't try to integrate it. If you do, you're like, oh, okay, so if that's true, then dy is equal to x plus y times what? Dx. Okay, then dy is equal to x dx plus y dy. Oh, damn it, y dy. Okay, I'll move it over there. Then I'm back to where I started. It doesn't help you, right? So when they say substitute it in, what does that mean? Here's the original differential equation, right? What did we think was a solution to it? Y equals what?
Minus x.
Y equals negative x minus 1, right? What can we do?
Plug it in
Exactly. And what happens? Not everything though, right? If we plug that in for y, what happens? Y prime is equal to x plus what? Negative x minus 1. What cancels? And what do you end up with? Y is equal to? Is y prime equal to negative 1 the entire time? Yeah, what's the slope of that line? So it checks. You can't integrate this though nicely. Ain't no nice integration for this. Ain't no nice integration. Okay, so let's play around a little more. Number 4, you had to do by analysis. I know it's annoying, but you got to do it by analysis. I'm sorry, it's just how it is. It's just how it is. Okay, what's the only variable in there? That's the first important thing to notice. Y is, yeah, y and what? T. So y is the output, but in the equation itself, t is the only variable. So what is c? What is a? What is k? Constants. Treat them as constants. We're still in single variable land. So when it says show that that's a solution, what does that mean you need to do to the differential? Integrate it. Yes, exactly. But what's the first thing you need to do, Nam, though? Separate. And can you separate on this one? Yeah. You see what happens there? dy dt. Oh, I just divided. So all I did here, what was that step? That's just simply what? Division, right? Are all the dt's alone and are all the dy's alone? Absolutely. Now what can we do? What are we prepared to do now? We can now integrate. How do you feel about that integration? Are you okay with that integration I did right there? kt plus d? You see how I turned the c into d? You'll see why in a second. We're going to have other constants. Theoretically, if I integrated on both the left and right, what do I have on both sides? Constant 1 and constant 2. You combine them and get what? One constant. As long as you have a constant and you don't have to put it on both sides. But you're not done yet. You want to show that that's a solution. What's isolated? Y. So what form is this in? What's that called? Log form. So what do we want to turn it into? What's it called? Begins with an E. Exponential form. Can someone tell me out loud, who hasn't spoken it, what's the exponential form for this? Soma, what is it?
It's
E to the
kt plus d equals y minus a.
Y minus a. Nice. Y minus a. Nice. Because ln is log base e. So what do you end up with? Y is equal to a plus e to the kt plus d. But how do you change? It's not quite this, right? You want this c to pop out there? Well, you just rearrange it. Y is equal to a plus what? E to the kt times what? E to the... And then what do you call that? Just call it a constant c. So do we now have it? Yes. You're going to see this equation hundreds of times in your life if you take more math. Absolutely. It's very common. Very, very common. But this is separation of variables and integrate. When you see a question like this on the free response section of the BC exam, you're going to be like, hallelujah, free 5 points. That's huge. These are usually 5 points. 5 whole points. Like that is usually 5 points out of 9 on one of the free response questions. Like just that. Sometimes 1 point is more work than that. So when you see separable differential equations, be like, yes, yes. You have to separate first. You see this first step, everybody? If you don't do that first step, guess how many points you get?
0.
Yeah, they're real hard about this. 0. You have to separate first. You have to separate first. Okay, but before we move on, let's look at these slope fields here. I love thinking of them as currents. So if I said sketch 3 solutions, this is just a really general thing. If it says sketch 3 solutions, what do you get to pick? Any points. So if I picked, for example, let's say this point right here, what does it look like? It's going to, kind of looks like this, right? Let's say I picked, I don't know, this one. What's it look like here? Kind of looks like maybe like this. Does it cross? I don't know, maybe. Kind of looks like it. Does it get kind of ambiguous when there's that many lines?
Yeah.
It does. The AP test is not this ambiguous. They give you at most, I think, 25, like a 5x5 grid. So it's really clear. This is like, oh gosh, I need my glasses, right? Like they're not going to do this dense. It's not going to be this dense. But plotting a solution is just pick a point. So for example, like this one, it could kind of go, whee, maybe like this. Maybe that's it. That's what it looks like. You follow the current. You follow the current. How do you match a slope field to a graph? Anybody have some tips or tricks? You had to do this last night. What did you do to match? Equals x is right there. Well, that's like about 0, right? So it's not this one, right? Let's just go down to here. What about this one? Well, that's 0, But look, now it's positive, and now it's positive, and then it's oh wait, it's not straight up and down, right? But look at this one. What's going on here? What are they all? They look like they're all what? You see that right there? So they're all undefined. So we really think it's that one. Let's be even more sure about it. We looked at the denominator. What about the numerator? What's going on when y is equal to negative x? What's the slope? 0. So let's go to diagonal. Are those 0? No, they're undefined. What about here? Are these all 0? But what about here? Oh, it will actually respond. What about this one? You see? They're all 0, right? See how they're all 0? So you can do it by elimination. Pick interesting points. It's a subjective term, but stuff will bounce out at you. Like, when is the denominator 0 and undefined? When is it 0? When is it 1, right? And again, the slopes, they're not going to do like, what's the slope of this line, everybody? They're going to be like 0, negative, or undefined. 0, positive, or undefined. They're not going to be like, which one's greater, everybody? Like, that's not fair.
What if an undefined slope look like?
Straight up and down. That's how it's visually done on a slope field. Because you go infinitely up for no horizontal movement. That's how it's visually done. That's how it's visually done. Anybody know what this kind of curve is called? What kind of slope field is that? Anybody remember? You might have seen it in your homework or in the book. Seen it in biology class? Anybody seen it before? Kind of looks like tangent, yeah. Whatever that carrying capacity is, get ready for, I don't know, The Walking Dead. I don't know, something happens. Something happens. Something happens. Basically, if you want my prediction, it's going to be a world war over water. That's my prediction. Drinking water is going to be the next thing. The first one. So delta y will be equal to, it's over y, not x. It's a y right there. 0 times delta. So 0.1 and in 1. So your first one is 0.1 and 1 because the first one is 0.
What's the second y 1? Oh, because you plus.
It's because the delta y comes out to 0.
And then you plus the y. Okay.
Yeah, you add, your next one is, so it's 1 plus 0 equals 1.
Okay.
Keep going. It asks you, is this going to be an overestimate or an underestimate? And you can't see the picture. If you were given this picture here, look on the right there. Is what you resulted, the number that you found, is that going to be an overestimate or an underestimate? Based on that picture, it's going to be an overestimate. There's one phrase in there which they did not fully substantiate. You can fully believe it, but we haven't proven it. Look what it says. Third line down, since the curve is concave down, based on what we've drawn, do we strongly suspect that it is concave down? Do we strongly suspect that it's concave down? Have we proven it's concave down?
Because it's like always the slope is going.
The slope is increasing at a larger and larger rate as x gets bigger. I agree with that, but the point is, they just say this right here. Since the curve is concave down, there's no justification written in. But one of the definitions for concave down is what? All the tangent lines are what? Above. Concave down means all tangent lines will be above. What does concave up mean? All the tangent lines are below. So yes, if you agree that this is concave down, then this estimate is going to be above. Because the initial tangent line, what's that initial tangent line going to do? It's going to go, wee, you're up above, and then you're going to stay what? You're going to stay above. You're going to stay above. Now again, how would you make your estimate better?
Make it less.
So for you, is this annoying? Yeah, it's fine to admit that. For a calculator, it's what? Trivial, right? So when you ask your calculator to solve differential equations, do you think it does calculus?
No.
If you consider this calculus, yes, you would consider this, but I agree with you. It's not actually integrating, right? Most calculators are not thinking about integrals. What are they doing? They're going to do Euler's method. What's their step going to be? Like 0.001? And then they're going to graph it. Like, hey, there's the graph of the solution, right? Have they integrated it? Nope. And then could they estimate the equation? Oh, sure, absolutely. Calculators can do thousands of computations. I don't know how fast T84 is, but very quickly. So let's do one more of these right here. Get back to the board. You can use your same groups. The other person can write this time. Please try this one for me.